What's up, everybody? Welcome to the Rosen Bridge presentation. Rosen Bridge is a trustless, ergo-centric second layer authentication bridge. One thing that I'm a big fan of in this setup is that it is very heavy into extended UTXO, meaning it uses on-chain and off-chain resources to try to create safe transfers. The end goal of this bridge is not necessarily to be fast. It's to be secure. And using the off-chain capabilities of extended UTXO, I think it's certainly one of the more novel engineering frameworks I've seen. So a special shout out to MHS Sam, who's put this initial design together. And I believe at this point, our first goal is to have a bridge to Cardano. The ETA at this point is estimated at 8 to 10 weeks. Now, one thing to remember is this is a work in progress. So that may be faster, it may be slower. Most important thing is we take our time and do it right. So what I'm going to try to do is take you through a visual presentation of the actions that this framework uses. That way you have a visual understanding, and then I'll get into the pros of this particular design. So the first thing we're going to look at is what it would take to transfer tokens from ChainX to Ergo. In this example, it looks like we're using Bitcoin, but any chain that's supported is going to follow relatively the same path. There might be some differences depending on the Nakamoto consensus or how long it takes to assume that you have secure settlement, but that's going to be adapted on a implementation by implementation basis. So we're going to start with this picture. I'll explain to everyone what they're looking at. Let's assume on the left, the orange part of the picture is Ergo. On the far left, we see the Sigma blocks going up at various heights. We see a little octagon. That's going to be called the guard bank, which is a part of this framework that is controlled by the guardians, but we'll get to them later. Now, in between the two parallel lines you see, orange and blue, you have green watchers. That is a set of off-chain actors that's going to act as the first layer of security in this bridge framework. Now, essentially, they kind of work like Oracle pools do, where you take distributed data from multiple sources and you post them to a single point, which is going to be on the Ergo blockchain. So their job is to sit off-chain and watch both sides of the bridge. So the first step would be a user on ChainX transfers to a multi-sig wallet that is going to be controlled by guardians. Now we'll get into guardians and what they do later. We will most likely have a user interface that's going to be built around that multi-sig wallet. Some systems support threshold signatures. That's probably a little bit better, but either one will work. So you as the user would send a token to the multi-sig wallet through the UI. That would be step one. Step two, the watchers are going to be, watching that multi-sig wallet. The frequency of that is customizable. So depending on how fast or slow a chain's block production is, we may try to synchronize every 1 block, every 3 blocks. That just depends on the computational resources that make sense. So step 2 is basically they're watching, and if they see a change in that multi-sig wallet, they get to work. This is a part of where we get into the benefit of extended UTXO. So the watchers, even though they are off-chain, have the ability to create boxes on the Ergo blockchain. So if payment is received into that multi-sig wallet, and there is enough verifications, depending on that particular chain's consensus, they're going to start creating boxes on chain on Ergo. So as ChainX continues to produce blocks, the watchers are going to continue to create event boxes on Ergo. And after a certain number, which is customizable and will be set depending on the partner chain, they have the ability to create what is called a approved event box. Now, an approved event box is going to be based on the general consensus of all of the watchers as they check the origin chain over time. Once an approved event box is created, the guardian set is notified. That's the verification set of actors. They also live off-chain, but they do have on-chain purposes on both ChainX and Ergo. So what they're doing is they're sitting off-chain and they're looking for a approved event box. When that happens, they're going to verify the validity of the events that happened on ChainX to make sure that the transaction event is valid. One nice thing that this creates is you have multiple stages of verification at multiple block heights. So the guards are going to be checking at a different block height, potentially even from each other. And the watchers are going to also watch a transaction as it kind of moves through the chain history. Now, after the guards themselves have done their homework and they have validated that the bridge transaction that the watchers approved is in fact valid, they're going to create a threshold signature on Ergo to approve the transaction. Now, what a threshold signature is it's a set of actors that are coming to some consensus over the validity of the event. And that's going to be what runs the multi-sig and distributes power between the guardians. So no guardian's individual signature will be able to activate a transaction. And guardians will not be able to act independently of the watchers. The watchers first have to create the approved event box, and then after checking that that is indeed valid, the guardians have to come to consensus that it's valid. Once that signature is signed, the guard bank will mint a wrap token and submit it to the user. Once that transaction has been submitted by the guardians, they're going to watch that transaction to make sure it's been broadcasted and mined and received enough confirmation that they have assurance that the user received the wrap token. So now we'll get into that same process in reverse. Let's say I have wrapped Bitcoin or ChainX token, whatever that is, on Ergo, and I want to send it home. We'll go through what that process looks like. The first thing that's going to happen is the user is going to send that token to the guard bank. And they're going to have metadata associated with their destination address, which again will be done through a UI. Once there's a change in the guard banks, the watchers, which are periodically checking for changes in bank box events, will register a change and see that the user has made a deposit, initiated a transfer. So when the watchers register the deposit or initial transfer with the guard bank, they're going to start creating event boxes on chain. And as the watchers create event boxes, which you can see on the left is progressing up in terms of block height, when there are enough boxes collected, the watchers create an approved event box. And what that does is it basically creates a notification for the guardians that they need to check the watcher's homework. So the guardians that are running off chain see the event box that's been approved, and they check the watcher's homework. If everything is good, they sign the appropriate transaction for ChainX. The guardians, once initiating the transfer, will sign for it and broadcast it to ChainX. At that point, the user's tokens are released and they are submitted via a transaction to the blockchain. The guards go through a process of tracking the transaction to make sure that it is mined and it receives enough confirmations to ensure that the user received their tokens. Now, these two frameworks, basically wrapping and sending to Ergo, or sending from Ergo and unwrapping, are going to follow very similar steps if we're talking about native tokens on Ergo or native tokens on ChainX. Essentially, the flow of actions is going to be pretty much the same. Now, we also have an interesting possibility that starts to open up where, let's say you have chain X and chain Y. Well, this bridge does open up the potential for a multi-hop transfer that is seamless, where you could send from chain X to Ergo and then from Ergo to chain Y. So layer 1 is the distributed off-chain watchers. In a way, they work very similar to how Oracle pools work on Ergo, where they're reaching consensus on particular data. They post a approved event box, and that notifies the second layer, authentication. The authentication is done by guardians, which are a set of actors that are going to be relatively well known. We're going to try to get projects that are competing with each other on top of the Ergo blockchain. That way there's no collusion potential, or it minimizes it at least. One of the reasons why it's nice to have a well-known set of actors for guardians is that they do inherent risk if they make a mistake. Where if they do end up signing a fraudulent transaction, well, their project is going to be potentially damaged by that mistake. Now, the guard set basically works with an M out of N threshold or multi-sig scheme, where the general assumption that a user can make is unless a majority of guards are corrupted, the framework is going to hold secure. We are also going to be adding a token staking and slashing mechanism. With the guards, the penalty for fraudulent transactions is going to be very heavy. So they do have money at stake. And the same is going to be true with the watchers. We're going to build in economic incentives for honesty. So the nice thing about this framework is that you don't need to add a new set of smart contracts when you add another chain. And what that does is it minimizes the risk when you're deploying a new bridge. There's bridge frameworks out there that use smart contracts on every new partnership, and that means that every bridge inherits new liabilities that potentially need to be audited. And it kind of builds out the potential for a point of failure. So if you look at how this works in terms of the on-chain aspects, aside from the guardians using multi-sig or threshold on another chain, everything is based on or off-chain on Ergo. And that's actually one of the nice things about this framework, is that you are hopping back and forth between on-chain and off-chain validation. having two different set of actors is also a pretty big potential in terms of the security, because the watchers cannot initiate a transaction without the guardian's approval, and the guardians cannot act independently without the watchers creating an approved event box. So not only are we trying to decentralize trust between the watchers and decentralize trust between the guards, but those two decentralized sets of actors have to work together in order to make this bridge work. Now, being that they're running on-chain, off-chain infrastructure, you also have the potential that the set of watchers are checking different height confirmations, and the guardians are also checking different height confirmations on ChainX or on Ergo, which means you're pulling from multiple potential data points. Partner chains need to support multi-sig transactions or threshold signatures. That's simply to support the guards having multiple sets of actors that need to participate in order to make anything happen. Decentralizes trust. There needs to be some message info or metadata support for the other chain. And ideally, once we have this framework set up on Ergo, it's pretty composable. There are some assumptions that we need to make about the speed and finality of other projects. And there's also the mechanism of multi-sig or threshold signatures that we need to take into account. But for the most part, it's pretty composable. So adding new projects, new blockchains should not be as difficult as working with a new set of smart contracts in another system. So this framework is relatively scalable in terms of computational cost. One nice thing about NepoPals is in the future, they do reduce the computational requirements off-chain. I imagine that will be more active in the future versus the initial build. And in theory, if you're wanting to participate as a watcher, that will be pretty easy, open source. We will have a mechanism where through multi-sig of the existing watchers, they can add new members. Sometimes that's a little bit messy in terms of, let's say, politics, but I think we can figure out a system that is more free, open, and fair. That's something that we need to take into consideration in building this bridge, is how to update the guards or add new guards as more projects build in the ecosystem. I think the more the merrier in this case. It decentralizes trust and makes collusion more difficult. But that's a bridge that we will cross probably in the future. So the nice thing is this design is pretty flexible and reusable across multiple blockchains. The cost aspect of it can be covered on the Ergo side, since all of the consensus transactions are based on the Ergo side. There is a potential that multi-sig wallets on other chains or in Ergo could be cold storage enabled, taking the funds out of a hot environment. Security-wise, almost all of the consensus that's happening is being done from Ergo, being that the guardians themselves represent the Ergo blockchain. The bridge does minimize external vulnerabilities. You have a lot of auditability in terms of the event boxes and approved event box and multi-sig transactions that are happening on the Ergo blockchain. And, the nicest thing is, again, it just minimizes external audits. That way, when you're adding a new chain, you don't inherit a new attack surface. So one thing I really like about this framework overall is that you have off-chain watchers that are verifying things off-chain and then posting on-chain. That then is seen from a different set of actors that exist off-chain, verify it off-chain, and then post on-chain. So it kind of uses the magic of extended UTXO to use your computational resources off the chain itself. And it also distributes trust in a nice way that creates kind of a multi-layer authentication, which hopefully provides a secure environment for cross-chain transfers. Now, this is not going to be the fastest bridge that is built for arbitrage and DeFi. It's going to be more for, I imagine, slower but more secure use cases. So thank you for tuning in. I hope you learned something about bridges anyway. It's definitely something that each user should be aware of the assumptions that they're getting into. Some bridges are simple multi-sig bridges. Some are, let's say, not as well distributed. And the reality is it's a choke point in our industry that I don't think there's a universal solution out there for. There's a couple of different builds that are all pretty unique, have their strengths, weaknesses, trade-offs. We think that having a lot of the logic anchored in an environment that we see and understand is going to benefit us long term. So thanks for tuning in.